So now that we've walked through the driver program for ImageStreamGang, let's go ahead and take a look at some of the different strategies using different concurrency and parallelism methods. Let's take a look first here at the sequential version, because that's kind of the baseline. We saw that that one doesn't perform as well as the concurrent versions, but it's easy to understand. So here is the ImageStream Sequential class, which extends ImageStreamGang. ImageStreamGang is a superclass, and ImageStreamGang is right here. And this keeps track of things like the list of the URLs to iterate over, the list of filters to apply. It also has some hook methods like process stream, which are overridden by each of the different implementations. It's got an initiate stream hook method, which starts timing, runs process stream, and then stops the timing. You can see this is basically a template method. And then we also have some other methods that do things like wait for all the processing to be done, and that way we can avoid having to duplicate code in our implementation. Let's see. Oh, we also have a method that gets the next input. Chunk is the next list of URLs to process. Here's a method that does blocking downloads. You can see it does call and manage block. So this will properly expand the underlying common fork join pool. There's a download image method that just downloads the image using the underlying Java mechanisms for doing image download. You can basically give a URL to a method called getInputStream, and then you can read from that stream and write it to the output. We got some methods that make a filter decorator with an image. We got something that's going to check to see if an image has already been downloaded, basically as a caching mechanism. We'll see how that gets used. There's a couple different cache mechanisms. And then we've got the mechanisms based here about how to time this. This was a very early program. Nowadays, I'd probably refactor this code in order to be able to have the timing its own separate class. One of these days, if I have time, I'll do that. It doesn't really belong here. OK, so with that as the background, let's go take a look at the ImageStreamGang, which extends ImageStream Sequential, which extends ImageStreamGang. And here's the process stream method. This is really the workhorse for all these different strategies. You can see the first thing it does is it gets the list of URLs, and then it converts that list of URLs into a stream of URLs. It then goes ahead and will check to see if we've already downloaded and processed the images. If we have, there's no sense in redoing it. So in that case, we're going to ignore images that have already been successfully downloaded and cached. So we're using filter to do that. Remember that. That's going to come in handy when we talk about other mechanisms besides sequential and parallel streams. If something has not been downloaded and cached before, we call the download image method. So for each of these different images in the list of URLs, we're going to download that image. Remember, this is sequential, so there's only one thread of control. And then we're going to apply flat map, because we're single-threaded, so there's no penalty for using parallelism, because remember, flat map doesn't work well with parallelism in parallel streams, but it works fine for sequential streams. We're going to apply filters to each of the images we've downloaded. So download image is pretty clear what that does. That just downloads the image. Once we've got the image, we apply the filters to it. And you can see what apply filters does. It goes through each of the filters, the null filter, the grayscale filter, the sepia filter, the tint filter, the emboss filter, whatever the filters are. And for each of these things, it's going to make a filter decorator for the image and then run that filter decorator, which will apply the filter and then write the transformed image to an output file. So that's what happens here for the sequential version of all this stuff. And then you can see the last thing we do is we terminate the stream, which, as you all recall, sets the wheels in motion. All the processing takes place, and we end up with a list of images. And then that's fed to the next part of the program where you can display the images or just keep track of how long it took to process them. OK, so that's sequential streams. Let's go take a look at the parallel implementation, which will have some things similar and some things different. So you can see here, the image stream parallel extends ImageStreamGang, so we're re-leveraging the framework. And then here's the process stream hook method, which gets a list of URLs. And then we're going to process those URLs, except this time, we're going to do it in parallel. So as you can see here, we're going to turn the list of URLs into a parallel stream of URLs. So now everything's going to run in parallel because of the magic of the underlying splitterator, parallel splitterator. We're running in parallel using the common fork join pool. In parallel, we get rid of images that have already been downloaded and cached. And then for the images that have not been downloaded and cached in parallel, we download them using blocking download, just like before. And then we go ahead and we apply map multi. Remember, we apply map multi here because this is a parallel stream, not a sequential stream. And if we use flat map, as we've done before, bad things happen. So we're going to apply the filters. This code here is exactly the same. Is it exactly the same? I think it's actually slightly different. Here is apply filters for parallel streams. It's similar, but slightly different than the other one. In this case, we're going to take the list of filters, and we're going to convert them into a parallel stream. So now we have a parallel stream of filters. And we're going to apply map to each of those to make a decorator, which decorates the image with the filter and then applies the filter and then stores the results. And this returns a stream of images, as you can see. That's what map does. And then for each of those images, we're going to apply the consumer to it. And then that will go ahead and essentially flatten the results into a stream. So we're using the map multi mechanism in order to be able to effectively do a flat map without incurring the limitations of flat map in a parallel stream context. So very, very similar approach. And then if you take a look at the results, as we looked at before, you can see that this parallel approach runs quite well. It's always in sort of the top of these things. But I think you'll agree with me that it's very similar in implementation spirit to the sequential streams version, and mostly just differs by using parallel stream instead of stream and map multi instead of flat map. So the nice thing about this is you get the benefits of speed up without having to do a lot of extra complicated programming.